So for the displacement, what does the displacement mean? So let's say a particle starts here at t equals 0, and let's say ends up here at t equals 3.
Can you maximize yours?
Oh yes, of course. Thank you. Oh my goodness. Thank you. Sorry. So let's say a particle starts here, does whatever, I don't know, but it ends up here. So at time t equals 0 and at time t equals 3. This is the displacement from the initial position till the final position according to the interval. But it can do this in the meantime. I don't care. So this is the displacement. From the beginning till the end. That's the distance. It can be 0 if it lands here in 3 seconds. It can be this. It can be anything. But it depends on the interval that we are having here. So displacement will be the integral from 0 to 3 from v of t dt, which is the integral from 0 to 3 from 3t minus 5 dt, and that is 3t squared over 2 minus 5t from 0 to 3. Luckily, I only have to plug in 3, so 27 over 2 minus 15. So this is negative 3/2, and the measurement unit, I didn't copy the measurement unit. What was it? Meters, feet? Meters. Okay, perfect. So like in my little example here, at time t0 was found here, 3 seconds later when it finished moving, for us between 0 and 3 is here. So this is negative 1.5 meters position wise. When we talk about the total distance, this will always be positive. Always. Why? Because it will be the integral from 0 to 3 from the absolute value of v of t dt. And there is a property of the definite integral. So if a function is positive or 0, then it's integral everywhere between whatever you want, between a and b, from f of t, f of x, dx will always be positive or 0. So if this is positive, this answer will always be positive. But I have to deal with this first. So I have to take the 3t minus 5 aside. Based on the formal definition of the absolute value, I have 3t minus 5 when 3t minus 5 is greater than or equal to 0. Or I have negative 3t plus 5 when 3t minus 5 is less than 0. So I have to deal with this first. And this will become 3t minus 5 equals 3t minus 5 for t greater than or equal to 5/3, and negative 3t plus 5 for t less than 5/3. So I know exactly, based on Mark's question from a minute ago, I know exactly where it will break. Because the interval is 0 to 3, and this is bigger than 0, smaller than 3. So this is the cutoff point. So my page 7. So then finally I can write that the total distance is the integral plus the integral from less than, from 0 to 5/3 from this one, negative 3t plus 5, please do not forget dt, and greater than, so from 5/3 to 3 from this one, 3t minus 5 dt. Now let me ask you if you have any questions before we continue. Any questions on this so far?
Which one are you doing right now, the displacement or the distance?
The displacement we finished.
Sorry.
That's okay. The displacement is this, and it can be any number. But the total distance will always be a positive number. Because remember a long time ago in chapter 2, when we determined the total distance covered by a particle going in any direction, positive, negative, we added up everything. We have to add everything is positive. Even if the direction is negative, it's still accumulating distance. So this will always be a positive number. So now I have to determine these two, evaluate these two integrals, and that will be the total distance. So negative 3t squared over 2 plus 5t, but from 0 to 5/3. And the other one is 3t squared over 2 minus 5t from 5/3 to 3. Okay, so negative 3/2 times 25 over 9 plus 25 over 3. Luckily, I don't have to plug in 0. Plus 27 over 2 minus 15 minus. Careful now. It's 3/2 but positive, and multiply by 25 over 9 and minus 25 over 3. Not friendly numbers, but I have no choice. Okay, let's see what I can do here. Negative 75 over 18 plus 25 over 3 plus 27 over 2 minus 15 minus 75 over 18 and then plus 25 over 3. Okay, these two, negative 150 over 18, so accounted for. These two plus 50 over 3, done with these two, and plus 27 over 2 and minus 15. The least common denominator, 18. This one a 6, this one a 9, and this one 18. So let's see what I get. Correct my numbers anytime. Negative 150 plus 300 plus 9 times 27 minus 15 times 18. I'm checking my numbers again. Negative 150. Yes, that's 300. 9 times 27. Negative 15 times 18. I got 123. And that is in meters. Any questions? Anything else? Anything else? Other questions? From homework, from WebAssign, from previous test, from anything you want on this list or other problems.
Can we do an example of definite with the fundamental theorem of R2? I don't have an example like this here.
Yeah. So it's this. This is fundamental theorem of calculus part 2. All this is part 2. This page. Or if you have a problem that you would like us to work on. But this is part 2.
No, that's it. I forgot.
Yeah, this is part 2 when you determine the antiderivative and then you plug in 5/3 and you subtract when you plug in 0. And then you plug in 3 and then you subtract when you plug in 5/3. That's part 2.
Can we go over another WebAssign problem?
Yes, yes.
It was used for WebAssign. It was chapter 5.5, question 13.
Very good. Let me share my screen. Oh, you said WebAssign. Sorry.
Correct.
This one, is this good enough, or you want to make up another, or you want to give us yours?
The version I had, instead
Yes.
of 6, it had 8.
Okay, so e raised to cosine 8t times sine 8t dt. Very good example. Thank you. Thank you very much. Okay. This particular situation has multiple layers. So the first substitution that I would like to use, any letter, it doesn't matter, u equals 8t, where du equals 8 dt. So I have this. I don't have the 8. That's really not a problem. And this will be u. This will be u. Everything else will change, right? I mean, will stay, but the integral will become an integral in u. So 1 over 8, the integral from this piece with this piece form the du. This one is e raised to cosine u. And this one is sine u. Now, this is what I don't like. So I'm going to say in level 2, I'm going to say let t be cosine u. As long as dt, which is negative sine u du, is in the problem, or it can be adjusted easily. Of course, I have this. I don't have that little piece, not a problem. I can put it anywhere, as long as I put it twice. So then the answer for now will be this, the integral from e to t dt. I recommend the 2 layers so you don't forget anything. So negative 1 over 8 e to t. Instead of t, I will write cosine u. Instead of u, I will write at plus a constant c. I recommend 2 layers because you may miss something and that will mess up the problem. So you understand why I needed 2 steps. One, because I had a function inside sine and cosine, and then I had another function inside e to the x. So this was my first layer, number 1, and this was my second layer.
And you're able to do the portion with eliminating the 8 by creating the 8 times 1 over 8.
Yes.
A neutral 1.
Yes. So if you don't like this, I think that the numbers are so easy to handle. But if you don't like this, just solve this equation for dt. So then dt equals du over 8. But you're going to get the same thing, right? It's really the same thing. So I think this is a shortcut, but if you prefer to solve for dt, just replace it. You will have du over 8, and then you put 8 in front anyway. Is that better?
This helps, thank you.
Thank you. Other questions? Anything else?
Would we ever have to do more than 2 layers of substitution?
No, 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 no,
Okay, thank you.
no.